Welcome to this 10th video of Mathematics Part 1, Lesson number 3, Polynomials of Standard 9. In previous video, we have seen the value of the given polynomial for the given value of the variable. Now, here we are going to see what do we mean by the, what are the remainder theorem and the factor theorem. So, to understand what is this remainder theorem or factor theorem, we are going to do one activity which is given in the textbook. That activity is divide the polynomial in x square plus x plus 7 by x plus 2 and find the remainder. This is the first step. Let's do this activity. So, we are doing this activity. First step, now we have to divide this 3x square plus x plus 7 divided by x plus 2. And what we have to do? Find the remainder. Okay. Now we have to just find the remainder. We do not want quotient. So either we can go by normal division method, or we can use the synthetic division method, or even linear method. But students, you know, just to find the remainder, synthetic division method is the easiest one. So let's go by that method. Okay. So for synthetic division method, what we want? We want the coefficient form of the dividend. What is the dividend here? 3x square plus x plus 7. So the highest power of the variable x is 2 over here. So there should be 3 terms. Second power, first power and the constant term, which we have here, x square, x and 7. So its coefficient form is very easy. Coefficient of x square is 3. Coefficient of x term is 1 and the constant is 7. Okay. As the divisor is x plus 2, we have to write its opposite number. Its opposite number is minus 2. That is opposite of plus 2. So we will do this synthetic division method. We will copy the 3 as it is. Okay. And then we have to multiply this minus 2 and 3. Minus 2 into 3 will get 6 minus 6, which you have to copy here. I hope you have watched the video on the synthetic division method. If you have not watched, you can watch this video specially made for synthetic division method. Okay. So now product of these two we have written here. Now do this addition of these two numbers, 1 and minus 6 addition is going to be minus 5. Take the product of these two numbers, minus 2 into minus 5 will get it plus 10. If you add these two numbers, it is 17. We put a box around this last number, which is remainder, okay, in this division process. Therefore, your remainder is 70. Okay. So now what this step we have finished, we have found the remainder. By any method, method is not given, you can use any method. Now what is the second step? Find the value of px when x is equal to minus 2. So in the second step, we are going to find p of minus 2. So px is replaced by minus 2. So this is your px, or you can write first px here. So let's copy px, 3x square plus x plus 7, and therefore p of minus 2, that is 3. Now x should be replaced as minus 2. So x square means minus 2 the whole square, plus x is replaced by minus 2 plus 7. Now we are finding the value, which we have seen in the just previous video. Okay. So 3 into 2 minus 2 the whole square is plus 4. Remember, square of any negative is always positive, because minus into minus becomes plus. Okay. Now plus into minus, when 1 is minus, 1 minus, it's minus. So minus 2 and plus 7. Take the product, 3 4s are 12, minus 7 plus, minus 2, this is minus 2 plus 7. 12 minus 2 is 10, 10 plus 7 is 70. So here also we have got the value of polynomial in x when x is equal to minus 2. What do you find? 70. So what is the third step? See whether remainder is equal to value of polynomial or p, when value of x is minus 2. So the third thing, that the remainder is equal to value of the polynomial when value of x is minus 2. You can see that is 17 and this is also 70. You can say from 1 and 2, you can say these two are 1. It is verified. We have seen if it is equal. Yes, it is equal. So what we come to know, actually we can verify the same thing with the help of any one more polynomial divided by any other divisor also. Okay. if we do that and if we find this, then we can come to the conclusion which I have written here for you, this one. Let me take one more example. Same activity if we follow for another this one. Let's see what we get. So let me take any say polynomial. Say we have taken another example too. Suppose we are dividing x cube plus 4x square minus say 3x plus or can say minus 2. If we are dividing this by x minus 1. Okay, suppose this is random polynomial I have taken, and here I have taken this divides. If we want the remainder over here, so what will be the coefficient for? It's cube, square, x term and minus 2 constants. So all these are in proper standard order. Its coefficient, let's take 1, 4, minus 3 and minus 2. Okay, so divisor is x minus 1. So if we take opposite of minus 1, it is going to be plus 1. So this number we will copy as it is 1. Product of this 1 into 1 is 1. Take this addition, 4 plus 1, 5. 5 ones are 5. Now this minus 3 plus 5, get it plus 2. Now 2 ones are 2. Copy down here. Addition of this is 0. So this is your remainder is here 0. So in the first step we found that remainder is equal to 0. Now the second thing what we have to find. Okay, when the divisor was x plus 2, we have found the value of polynomial is minus 2. So if it is plus 2, we have to find minus 2. So here the polynomial in x is x cube plus 4x square minus 3x minus 2. Then what we have to find? We will replace this variable. Divisor is x minus 1. Let's take opposite of minus 1 as plus 1. Okay, plus 1. Here plus 2. Here we have taken value of x minus 2. So here what is minus 1? We have taken plus 1. Okay, so here this is going to be 1 cube plus 4 in bracket 1 square minus 3 into 1 minus 2. So 1 cube is 1, 1 square is also 1, 1 into 4 is 4, minus 3 ones are 3, minus 2. So 4 plus 1 is 5, minus 3 minus 2 is going to be 5, 5 minus 5 is 0. Okay, so what did you get? So here also you found that this remainder is equal to, which is 0, we also got 0, P1. So what conclusion we can come to here? That if you see this note over here, so if polynomial in x, it can be x, it can be y, it can be m, so any polynomial with any variable, so here this polynomial x is divided by x plus a. X plus a, where a is a constant, x is a variable, a is constant, then the remainder is p of minus a. Okay, means where the divisor was x plus 2, so x plus a. So that remainder which we got in the previous sum, which was 70, which was equal to a, p is equal to p of minus a. So if it is plus a, it is becoming minus a. Where a is a real number. Where a, what is a? It's a real number. So real number means it can be, it is not only applicable for this 2 is a natural number, whole number. But it is not applicable to natural whole. It can be integer, it can be fractional, that is rational, irrational. So any this number, that means real number, it is applicable. Okay. And this is nothing but this is called as a remainder theorem. What is that? Remainder theorem. Means if the given polynomial is divided by x plus a, your remainder is equal to its p of minus a. This is the remainder theorem. So you get this same. Okay. Now, what if it is x minus a? If your divisor is x minus a, then you have to take here plus a. So whatever here we have that a value of a, its opposite we will take for the value. Okay, so that you have to understand. Okay, so in this way we have come to the what is this remainder theorem. Okay, now in the second example, first example the remainder was 17, the second example the remainder is 0. So what do we know if any dividend is divided by a divisor and your remainder is 0? What do we call in that case? You know that in that case we call that divisor is a factor of the dividend. Means for example, if I divide 15 by 3, okay, then what will happen? Quotient is going to be 3 5s are 15 and the remainder is going to be 0. So when there is a remainder is 0, we call this divisor is a factor of the dividend. Means we can write 15 as 3 into 5. 3 5s are 15. So 3 is a factor of 15 as well as 5 is also factor of the 15. So when the remainder is 0, we call the divisor which is called as factor of the dividend. So here if we are getting the remainder is 0, it means x minus a is factor of this dividend. Okay. So when the remainder becomes 0, we get the 0, it is a factor. So the same thing is given over here. Note number 2, if p of minus a is 0, p of minus a is 0, then x plus a is a factor of px. It is called as a factor theorem. Means for the given polynomial in x, the divisor is p of x plus a. To get its remainder, we will find this value p of minus a. Okay, and if this value is 0, then x plus a is a factor. And of course, if this is not 0, then it is not a factor. Means apart from 0, other than 0, if you have some other value for this, then it is not a factor. Okay, so this is called as a factor theorem. So here in this video, we have seen till now that what is the remainder theorem and what is a factor theorem. Okay, let's solve one or two questions based on this. So with the help of which you will understand how to solve sums based on this. Okay. So now I am going to take this question number question number 5, practice set 3.5, question number 5. Okay. This question number 5 is divide the first polynomial by the second polynomial and find the remainder using the factor theorem. Okay. So the first out of that, it is x square minus 7x plus 9. We have to divide it by x plus 1. So this is the division. So we have to divide the first polynomial by the second polynomial and find the remainder using the factor theorem also. Okay. So let's divide this. We can divide by any method. It is x square minus 7x plus 9. We have to divide by x plus 1. This is a normal method I have chosen over here. Okay. So if first term x square is divided by x, what you will get? This quotient is x, which we copy down here, and now multiply with x and x plus 1. We get it x square plus x, which you have to copy this product x into x plus 1. It is x square plus x. Subtraction, changing the sign, this will get eliminated. Minus 7x minus x, you get it minus 8x plus 9. Okay. Now here the one step is over. Now take this minus 8x, divide it by this first term x, you will get it minus 8, copy down here minus 8, multiply this minus 8 with the divisor x plus 1 and then minus 8x minus 8. So here it is minus 8x minus 8. To subtract, you have to change the sign, and plus 8, 9 plus 8, you will get it plus 70. This is your remainder. So quotient is x minus 8 and the remainder is 70. Now after this division, what you have to find? Find the remainder using factor theorem also. Okay. So after this we have to find the remainder by factor theorem. Okay. So polynomial in x is dividend, that is x square minus 7x plus 9, and for factor theorem the divisor is x plus 1. We have to take polynomial in plus 1 will become now minus 1. Whatever we have here, a, we have to take its opposite, a minus a. So this will become minus 1 the whole square, minus 7 in bracket, this minus 1 plus 9. Now let's see the value of this. Minus 1 square is plus 1, minus minus plus, 7 ones are 7 plus 9. Now this is 7 plus 1, 8 plus 9 is again 17. Okay, so we find that by factor theorem the remainder is, by factor theorem, actually by remainder theorem we write just what is a remainder, but it is given in the question that find the remainder using factor theorem. The remainder is 70, and we can add to this that the given divisor is not the factor of the first polynomial. So the second polynomial is not a factor of the first polynomial. We can add to this. Okay, and now let's see the question number 7. Whether you have to decide whether the given let me read the question for you. Use the factor theorem whether, what is question number 7? Use factor theorem to decide whether x plus 3 is a factor of x square plus 2x minus 3 or not. This is our question. Okay, so I have written in short. So using factor theorem we have to determine this. So how can we determine this? So for this answer we will write first polynomial in x, which is x square plus 2x minus 3. Now we have to decide whether x plus 3 is a factor or not. So if it is plus 3, we have to take polynomial of plus 3. Its opposite is minus 3. So it is minus 3 square plus 2 in bracket minus 3 and this minus 3. X is replaced as minus 3 here, and minus 3 is a constant which we have copied as it is. So minus 3 the whole square is 9, plus into minus minus 2 3s are 6 minus 3. 9 minus 6, 3 minus 3, we get it 0. Okay, so what you can say as p of minus 3, that remainder is 0, by factor theorem, x plus 3 is a factor of given polynomial, that is x square plus 2x minus 3. So this is our answer. Okay, this is our answer statement. Yes. So using the factor theorem, that if this value is 0, then x plus a is a factor of the given polynomial. So in this way you can decide whether the given divisor is a factor or not. Okay, so in this way you can solve the remaining sums of this practice at 3.5. I hope you understand this concept of remainder theorem and factor theorem. Actually it is not very much different. Whatever remainder, that is remainder theorem. We get it as value, that is remainder theorem, and if this value is 0, it is a factor. That's it. These are the simple two things, these two notes. If you remember, this sums will be easier for you. I hope you have understood this. Then please like, give me your comments, forward it to your friends, and if you are not yet subscribed to the channel, please subscribe, and don't forget to press the bell icon so that you will get the notification of the next video whenever it is uploaded. Thank you very much.